Hello, everybody, and welcome back to the third of these series of operations performed on complex numbers. And of course, welcome back to Funland Tutorials. And today we'll be, as mentioned before in the previous weeks, today we'll be talking about division. Since division does use multiplication of complex numbers, I will be linking multiplication of complex numbers somewhere up over here in the cards, and I will also be linking them down in the description box below. And if you have not watched that video, I do highly recommend that you look up that video, because we will be referring to that video. Basically, we'll be referring to this portion that we did last week. And so let's not waste our time further, and let's look things up. So again, in today's video, we'll again be looking at the same complex numbers. The standard: z1 equals a1 plus b1i, z2 equals a2 plus b2i. And what we'll be doing today is actually division. So that will be z1 by z2, right? That is what we'll be doing today. We have been waiting so long for this. Okay, so let's use the same trick that we did in terms of multiplication. So we just write the expressions first before we actually start with the mathematics of that. So let's write z1. So what do we know? Z1 is actually a1 plus b1i, right? That's what we know already. We know that z1 is a1 plus b1i. We've pretty much learned this up, haven't we? Okay, so a2 plus b2i, that's the expression for z2, the second complex number that we have learned, right? Now starts the part that we were dreading, if we are to say, but not so much. So now we'll be using a trick, right? We'll be doing something that we usually don't expect. What we'll be doing is we'll be multiplying something in the denominator and the numerator. What we'll be multiplying, that's the question. Okay, now what we'll be multiplying is, we will be multiplying another complex number. Now how do we know which complex number to multiply? Simple. We will be looking at the denominator. So let's look at the denominator. And where is my highlighter? Okay, this is my denominator, this is the real part, and this is the imaginary part, right? Now if you have watched my video on conjugate, I could have very well said that I'm multiplying the conjugate of this. If you haven't, then what I'll be doing is, I will be, if I don't remember if I've introduced conjugate or not, but if I haven't, I promise you, the next video that I publish will be that of conjugate numbers. So what happens is, I will be multiplying a complex number which has the same real part, but the imaginary part is actually of opposite sign, not plus. So it's minus. If it's minus, then it's plus. So opposite sign, not necessarily minus. Whatever sign I have here, the conjugate actually has the opposite sign. So let me just, in brief, conjugate of a complex number is pretty easy. What happens is, if you have a complex number like this, the conjugate of that complex number will be a complex number which has the same real part. So a2 sign does not change. A2 sign remains the same. So a2 here positive, and a2 is positive here as well. Had a2 been negative here, we would have kept the negative part of it as well. The imaginary part is what changes. Complex number is all about imaginary numbers, so everything is related to imaginary numbers. So the imaginary portion of that complex number changes. So basically, this is called the conjugate. In this case, this is the conjugate of the denominator. So I'm multiplying the conjugate of the denominator with this. Now, if I'm multiplying something with the denominator, I can't just keep everything, because that will change the expression, right? So what I have to do is, I have to multiply this in the denominator as well. Now, can I? Actually, no, I can't, I guess. Can I? I don't think so. So I'll have to write that again. So essentially what we do is, we multiply the same thing, the very exact same thing in the numerator as well. Right? So that doesn't change my expression. I have multiplied the same thing in the denominator and numerator. Now comes the multiplication. So again, if you haven't watched my multiplication video, I do suggest that you watch them up, because I will not be explaining the entire multiplication process. What I'll be doing is, I'll just be using this expression that we came up with in the multiplication video, and I'll be just writing that down at one go. So I highly suggest that you look the video up if you haven't, because you otherwise you won't be understanding why in the world did I do this. So what I'll be doing is I'll be looking at the expression. So what I'll have is I'll have a1 a2. Okay, what was that? A1 a2. Now in my original expression both of them were positive, but here b2 is negative. So what I'll have is I'll have a1 a2 plus b1 b2. Okay, I hope it's clear. It's of course clear, right? B1 here, b2 is negative, so if I take b2 to be negative, this is positive, right? Very clear. And when we talk about the imaginary part, this b2 is negative, so instead of writing a1 b2 plus a2 b1, let me write a2 b1 minus a1 b2. Okay, because b2 is negative, again b2 is negative, so in this expression we get b2 to be negative. Now watch closely that what happens in the denominator. Let's think about um, let's think about it in this way. This is one expression, call this let's take a different color. So this expression is x, right? This expression is y, this expression is actually x, this expression is y. Now what happens is you can express this as x plus y into x minus y, right? X plus y into x minus y. Why does it look so familiar? If it does look familiar, then good, because x plus y times x minus y is actually x squared minus y squared. Simple as that. That's x squared minus y squared, right? So instead of going through the pain of doing all the multiplication, we can just use a formula. So we write x square, which is actually a2 here, so we write a2 square, and I'm gonna leave some space because I'll be changing some things. It should have been minus y2 square, right? So minus y2 square is actually minus b2i square, minus b2i whole squared. I Okay, that looks prettier than the previous one. b2i squared, right? Now instead of that, I can also write it this way: b2 squared I squared, right? Of course we can write it that way. Again, I squared. Let me remind you what I squared is, if you haven't forgot, if you haven't if you don't remember, or if you have forgotten. I square is actually minus 1, so we'll be replacing that here again. So what we are left with actually is where's my eraser? Yeah, instead of writing a square over here, and yeah, that is what I was worried of. Let me write that expression again. So instead of writing b2 square I square, we can actually write positive b2 square, right? There was this little cheeky little I square here, so instead of writing I square, I am writing minus 1, so that's b2 square times minus 1. I can just push it in front of the expression, and because there was a minus over here, that gave me a positive sign. So we actually have a very pretty little real number in the denominator, something that doesn't have an imaginary part. So now, to make things again prettier, because mathematics is a very pretty subject, of course it's a very pretty subject, sarcastically. No, it's really pretty subject. If you get things right, then everything falls into place, and it's a very symmetric subject, I feel. What do you feel about mathematics? Let's talk about that. Let's write that down in the comment section below. What do you feel about mathematics? How do you like it? Do you like it? Do you love it? Do you hate it? Are you ambiguous about it? Okay. So what's our first expression? First expression, let's look at the real part first. So a1 a2 plus b1 b2, and in the in the denominator we have a2 squared plus b2 squared. We have that, right? Now let's look at the imaginary part. Now we can split up the denominator, right? We instead of some when we write a by b plus c, we can write it as a by c plus b by c, right? So that is what we are doing here to make things we get a real part and we can get an imaginary part. That's the standard form of a complex number. So that is what we are trying to get to. So now we have the imaginary part. So that's a2b1 minus a1b2. Okay, and then we are very strong in mathematics. We have a strong foundation, and we do not forget to write the denominator, right? Please do not write to forget the denominator. Please don't think that I've written denominator in the first part, so the second part is already there. Do not do that. Okay, we are really strong in mathematics with a strong foundation, and we are also strong enough to not forget that there's an I over here. Okay, so we have a1 a2 plus b1 b2 by a2 square plus b2 square plus a1 a2 b1 minus a1 b2 by a2 square plus b2 square times I. So this is the real part of the quotient, and this is the the imaginary part of the quotient, which actually tells us that complex number divided by a complex number is actually a complex number itself. That's actually, in some books, that is written as a corollary, that when we add two complex numbers, we get a complex number. When we subtract one complex number from one complex number, we get a complex number again. When we multiply two complex number, we again get a complex number. And if it was not obvious, if we divide a complex number by another complex number, we get another complex number, which has this real part, a pretty substantially huge part, and again a very substantially huge imaginary part. So that is actually what there is to the division of complex numbers. In the next videos, we will be talking about uh, properties like inverse and identities. These are actually advanced operations, and we'll be looking at multiplicative inverse, multiplicative identity, additive inverse, additive identity. Again, I will probably be splitting them up into separate videos, because I do feel that when there's a very long video, it tends to become repetitive and it tends to become boring. So I have decided that I'll try to keep to a time limit as much as possible, and I hope you're enjoying these series as much as I am, because I really love to share whatever I have with a lot of people. Do share your ideas and share your positive criticisms on the videos that I'm creating, and of course, like, comment, share, and subscribe to these videos. Subscribe to my channel and like, share, and comment on my videos. So see you next week.